What's going on YouTube? This is Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today we're going to be talking about another one of my favorite packages, and that is Pandas. For those who tuned in to my NumPy tutorial, this goes hand in hand with NumPy, and a lot of the times you're seeing these two together. It's a data processing tool. You're able to input a whole bunch of data formats like CSV files or Excel files, and you're able to quickly manipulate the data that's within them and reference different cells to allow you to quickly pre-process data and get it ready for machine learning. So without further ado, let's jump into the tutorial. Alright, swapping over, we can see I have a blank Jupyter notebook open and we are ready to get started. So one of the very first things you need to do is you need to download Pandas. Like NumPy, if you are using Anaconda, you do not need to download Pandas as it's included in their data science pack. But just in case for some reason yours was deleted, or if you're using some other Python scripting tool, then we'll go ahead and do that right now. So in order to download it, it's a simple conda install pandas, or if you're using pip, same thing, pip install pandas. I'm not going to run those obviously because I have them downloaded already, but you can run them through your Jupyter notebook, or you can run them through the command line. I'm going to move on to, once you have them downloaded, we are going to import the pandas module. So that again is a simple import pandas, and typically you see it as PD. Like NumPy, it's just easier to reference. You're going to constantly be using it, so it's just shorthand for it. I'm going to also import NumPy. Like I said, these go hand in hand. I'm not sure if I'm going to use it in this tutorial yet, but just in case, I'm going to have that up there. And I will print my versions just to show you guys the versions I'm using. Again, if something happens, you get an error, some of the steps that I'm doing don't work for you, it's possible that you have a different version running. So just check with what versions you're using. You may need to upgrade yours, or if you're using a newer version than mine, maybe the documentation has been changed, so you need to go check that out. But I'm using 1.34 for Pandas and 1.19.2 for NumPy. So like NumPy, Pandas has a built-in array, except for they call theirs a series. So in order to define that, you can use pd.series with a capital S, and you can put in some array. Just do array of 5 elements right now, and I'll print that so you can see what it looks like. So the difference with Pandas is it's going to add this index column for all of your values. On the left, you can see index column. On the right, you can see what those values are. That's just a byproduct of using Pandas. And you can reference them using those index values. So I'm actually going to make a few more of these. I'm going to call these X, Y, and Z. And we're going to change up these values a little bit. I'm just going to use random numbers. Okay, so I have 3 series of 5 elements each. I'm also going to make labels for my columns. So I'm going to call this X, Y, and Z. So this is just a list of characters. And you're going to see I'm about to use these as my data frame columns. So a data frame is a collection of a whole bunch of Pandas series. So it's basically a table that you're going to be able to reference and manipulate. So df for data frame, I'm going to say pd.data frame, again, capital D, capital F. I'm going to say list zip, and here's where I'm going to put my data. So in this case, I have the values of X, Y, and Z. And then I need to assign those lists a column header. So columns equals, and I have that variable for cols. Now, there are a couple ways of displaying these data frames. First, you can just print it using standard print df. As you can see, prints it out. The left is the index column, and the top are the column headers, obviously. Just going to separate this a little. But the better way of displaying data, it's just going to be cleaner to see, is using display. That is a built-in function for Pandas to allow you to easily view this data. And it's just going to put it in a more structured table. All right. moving on. So not only can you create your data frames, but you can actually read them in. So you can read them in from Excel files or CSV files. I typically use CSV files, so I'll show you how to do that right now. So again, I'm going to define a variable of df for a data frame, and I'm going to say pd.read_CSV, and I'm going to say whatever the CSV file is. In this case, I downloaded a typical beginner machine learning one, and that is the housing prices. I got that from Kaggle. I can put a link in the description for that as well. But I saved it as houseprices.csv. So now if I go ahead and I display the data frame, you can see now that I have a whole bunch more rows and columns. I actually have 1,400 rows and 81 columns, and you can scroll over to see others. Not all of them are displayed, as you can see right here, these 3 dots, and then the 3 dots here, so you're not going to be able to see everything from this just a standard display. You can, if you print it, you'll be able to see everything, and there are ways of displaying absolutely everything in the data frame, but for now we're not going to cover that. Additionally, you can see that the data frame actually included an index column, but Pandas went ahead and made their own. So in order to, if you know that up front, you can actually just assign the index column straight through this. So if I say index_column equals that column name, and make sure to put it in apostrophes, so I can say ID is my index column. And now if I rerun that, you can see the index column is now reassigned to that ID column. Okay. All right, and moving down. So there are different ways of displaying it. This will just display the top and bottom. Now if I wanted to see the first X amount of elements or rows within the data frame, I can say display df.head. And if I run that, you can see it gives me the first 5 elements. If I want more than that, I could say give me the first 15. So I would just put 15 in there. It'll give me 15 elements. Instead of head, I can also do the tail. So this will give me the last X amount of elements. So I can say tail. And as you can see, it gave me the last 5. So just different ways of seeing what's in the data frames. Okay, other useful information that you're able to see, just like NumPy, there's a bunch of built-in functions that you can use to get a whole bunch of useful information. So if I say df.shape, you can see that I have 1,460 rows and 81 columns. And that's 81 now because index column will not count. I can do other things such as print the d-types of all my elements, of all my columns within the data frame, and it's going to tell me the column name and what the values under it are. So you can see some floats, some objects. You can also do df.columns. That is going to print all of your column names. Same thing if you want to print your index values, you can do df.index. And if you want to just print all the values without any index or columns, you can do df.values. I'll just print these out and show you. Here is your header values, column values. Here are your index values, and here are the values within it. And you can see the values within it. Each row is saved as its own row within this data frame. Within this list. If you want, you can save columns instead. You just have to go up here to the values, and you do, if you remember the NumPy tutorial, .t will transpose the data. And you can see now the columns are saved in individual lists instead. Lastly, if you do df.info, this is just going to print out a whole bunch of useful info about the data frame. Scrolling down, you can see the number, the column name, how many non-null elements are within that specific column. As you can see, most of them have a full column, but like this one only has 91 values. The rest are not in numbers. and what the D type is of that specific column. And going down, you can see how many columns were float, how many columns were integers, and how many columns were objects, along with how much memory was used for this data frame. So a bunch of useful things that you can get out of it. So moving on, sometimes you only want to reference maybe a couple of the columns. You don't want the full data frame. So you can actually do that really easily within Pandas. So if I say I want the data frame and I only want the building type, so that's BLG type. Okay, this is only going to print the building type column. So here's the index values and here are the column values. Now if I want more than just one, I can use a second set of brackets, and I can say I want the sale type as well. And finish off that bracket there. So this is going to pull both the building type column and the sale type column. So that's how you reference columns within the data frame. I'll show you how to reference rows now. So sort of the same thing. So I'm going to display df, but there's a function called locate, so LOC. And within the brackets, now I'm going to put the index value. And this is unlike NumPy or a Python list where you can say the first element is index 0. Since Pandas has its own built-in index, whatever this value is on the left-hand side, that is going to be the value you need to put in here. So if I pull I'm pulling the value of 100 in the index column. I'm not pulling the 100th element within the data frame. Although in this case, since my index column is incrementing by 1 and is starting at 1, it will end up being the 100th element. But I can go ahead and print that, and it gives me all the values for that one element. Now, if I want to do more than one, let's say I want to find the 100 index and the 200, I can do sort of the same thing with the double brackets here, and I can print those out. So as you can see, 100 for the index and the 200 for the index gives me the rows for each of them. Other super useful things, I'm just going to create a temporary variable, and I'm going to call it temp. But I'm going to say temp is equal to the data frame, and then this is looking for an index, right? So it's looking for, if I say the data frame where the data frame, so using df again, and now I'm going to say what column I want to reference. So I'm going to say years sold. So I want to know where the years sold was greater than 2008. And so what this is doing is saying, in the data frame, find where the data frame is greater than 2008 and put all those indexes, or show me all those indexes. So if I print temp real quick, you can see that it printed those. So sorry, let me change this to a display just to make it easier to see. As you can see, when you have a large amount of data, printing it is fairly hard to go through all the items because they loop around. So displaying it, you can actually scroll over instead of having to scroll down. But I'm looking for the years sold, and as you can see, they're all greater than 2008. Now, when you do this, the index does not reset. So it's going to take all the index values, and again, it's unlike NumPy and it's unlike just a Python list where the 0th element is the first element. If I want to change that, I can actually go in and I can say temp equals temp.reset index. And I can actually say drop equals true. So what drop is if I were to reset the index without it, it's going to take this original index and it's going to make it this new column. And I don't necessarily care about preserving it, but if you do, you can set that to false, so you're just not even include it because that's the way it will be included. So if I do it again, the index is now starting at 0 going down to the end, which is 512 in this case. Other ways of doing this, if I don't want to reassign the variable, I can actually just get rid of that first part, and I can add another element to here that says in place equals true. So this is saying just reset the index in place. It will automatically reassign it to whatever data frame that you're trying to adjust up here. I'll just run that to show you, and again, it resets that initial index. Okay. All right, so sometimes, so that was just for one variable. You can reference multiple variables. So if I say I want a temp variable where the data frame at the year sold, I want to get all the values where that value is in some list that I give it. So I want to know when it's in either 2008 or 2009. And put those in brackets if you have more than one. And what that's going to do, if I display temp, it is going to, let me scroll over, find the year sold, and if it's in 2008 or 2009, it's going to print all those indices. And again, the index was not reset, so if it helps, you can reset it. If you need to reference those and you don't want to worry about what the actual index value is, resetting it will help you out and put that back to 0. Okay, other useful things. Sometimes you have multiple conditions that you need to be true, or want to be true. So you can have temp equals the data frame where, and now I'm going to have multiple conditions. So I'm going to put my first one in parentheses, and I'm going to say where the year sold, let's say, is equal to 2008, and that is a double equal sign for the condition in the beginning. And now the ampersand sign will say, and so I need both conditions to be true. So let's say the sale price, I want the sale price to be greater than 150,000. That is 15,000, 150,000. So temp is going to be where the year was equal to 2008 and where the sale price was over 150,000. So let me display temp and scooch over. All right, so obviously these are all, the year was 2008, and these are all prices over 150,000. So that works for the and. You could also say or using the vertical line, and this is going to say if the year is equal to 2008 or if the price was over 150,000, then print either of them or all of them. Scrolling over, you can see some of these are equal to 2008, which we'll print it for, but the ones that aren't, it's actually over 150,000. So that works for and or, and you can do those for a whole bunch of different conditions. Next, it's useful to know some information about your columns or rows. So you can actually display, and I can take the data frame dot describe with parentheses at the end because it's a function. And displaying this will give me, and this is for only those that contain floats or integers. So anything with a number. It won't do this for strings for obvious reasons, but it's going to tell you the column name, and it's going to tell you how many values are within that column, what's the mean, standard deviation, min, max, percentiles, and it's going to give you all that information for the ones that contain numbers, not strings or any other type of variable within inside of them. If you want to just individually do this for a column, you can actually just say print the data frame at say you use sale price, and I want to know what the mean sale price was, so I can say dot mean, and this is just going to take the mean for that one column. It'd help if I spelled price right. And so there you can see it took the mean, and the mean sale price was $180,000. Other useful things, print. So I can print the number of unique values that are within a specific column and how many of them there were in the column. So I could say the data frame at, let's just use street, and I want to know the value counts of each of the items within there. So value underscore counts with parentheses at the end, and if I print that, you can see there are 2 unique items within the column, and pave shows up 1,454 times and gravel only shows up 6 times. So you can do that for individual columns to see which values are in there and how many of each are present. Next, if you only want what values are unique, you can say, let me find a column that's has a little more to it. So if I say the data frame at year built, I can say give me all the unique values by using .unique, and this is going to spit out only the unique values within there. If I want to know how many there are, I can actually pretty much take this function I just made, and I can say n unique for number unique, and I will print that out, and there are 112 unique items within that column. Okay, not only can you get useful information, but you can also just manipulate the data frame. So one thing you can do is you can actually just drop values from the data frame. So if I say temp equals the data frame dot drop, I can say I want to drop the alley column. And I have to specify which axis, so I can say axis equals 1 because it's a column. So axis 1 is a column, axis 0 is a row. So now if I display temp, let me just go back up here. May not be able to see alley in this one. But there is no alley in this bottom one because we just dropped it. If you need to drop more than one, you can put this in brackets. And you can say, let's get one that I can actually see. Let's drop this street column. Okay, I want to drop the street column as well. So you put it in brackets, and now the street column, which was right here, is now gone. All right, next you can copy the array. So if I say temp equals df.copy, it makes a copy of it. And I can start adding columns instead of deleting them. So I can say, some random variable values is equal to the data frame at the lot area. I want to say what's the ratio between the lot area and the sales price. So I can divide that by the sale price. And if I print values, you're going to see that it just goes through and divides those two values and gives me the results. Now, if I want to save that to the data frame, I can say, and I can make a brand new column. So make sure that the one you're about to add is not already in the data frame, because that would just replace it. So if I said lot area and I set this equal to values, it was just going to override everything in lot area. So I'm just going to create a brand new column by putting a new name in here. So I'm going to call this area per sale price, which is what I just did. And if I go down here and now I display temp, we're going to be able to slide over, and you can see a brand new column pops up with those values that I just calculated. And it's going to add it at the very end. Okay. Moving on. If I have, let's do temp equals df.copy again, and I'm just going to display temp. Okay, and I'm looking for pandas and numpy are the same in that they are going to add not a number for variables that aren't there. So there are ways to handle that. First thing you could do is you can just drop anything that's not a number. So you can do temp.drop na. So this is dropping not numbers, and I'm going to say in place equals true. So what this is going to do is it's going to go through each row, and if a row contains not a number, then it's going to drop the entire row. Hopefully we'll have some rows in here to be able to see. Actually, let me display temp. Actually, we don't have any rows. That's all right. We can. So what that means is every single row in here contains at least one not a number in one of their columns. So instead, we can just go ahead and fill the NAs. So if we fill NA, we can say I want to fill them with -1000. And now if I go ahead, where these not a numbers were, you can see are now the value 1000. So that's kind of a way to just deal with it. And you can do these individually by saying if I want to fill alley. I'm sorry, let me put that here. All right, so I only wanted to fill the alley column. I can do that as well by essentially overriding the alley column and filling it with -1000s. So you can see the alley column, it took all the NANs and filled it with -1000, but everything else stayed as NANs. So that's how you can do it for specific columns. Okay. Now you can sort values within an array. So I can just say the temp equals the data frame dot sort values. So this is going to sort all the rows within the array based on whatever conditions you're about to give it. So I can say I just want to sort it by sale price. And I can go ahead and display temp. And what this is going to do is, obviously you can see our indexes are all messed up now because we are sorting it by the sale price. And this is in ascending order. If you want to go in descending order, you can come back up here and you can add another item that says ascending equals false. And this is going to put it in descending order. Maybe spell ascending right first. Go ahead and run it. And as you can see, sale price is now decreasing with the highest on the top. If you want to have a second condition that you're sorting by, I can add a comma and put maybe year sold here. So now it's going to be sorting by sale price first and then year sold second. So if I go down, it's sorting by, and I don't see any sale prices that are the same. But if the sale price was the same, it would go to year sold next to sort by. And the last thing I'll show you guys is how to save your data frame once you've manipulated it enough. So I can say temp.to_CSV and come up with a name for it. So I'm just going to call this housing prices 2.csv. And this is going to save the entire thing. Now, if you don't want to save the index column to go with it, you can actually just say index equals false. So it's only going to save the values and not the index column. And I'll go ahead and run that, and it will save it to my drive. So that's all I have for Pandas. Again, it's a lot like NumPy. They go hand in hand, but both tools are just amazing tools to quickly manipulate your data and quickly read in your data. So you're going to get very used to using these two, especially when you start working with machine learning data sets. I hope you guys enjoyed this. If you got anything out of it, please hit that like button. If you want more videos like this, definitely subscribe to the channel, and I will see you guys next time for the next tutorial.